Okay. So next section is 2.3 on conditional statements. There's another way you can combine two statements, and oftentimes most of the theorems you've seen in like a calculus class or other math classes, they're often in this form, a conditional statement. If something is true, then something else is true. Okay, so a lot of things that we'll prove this semester will be in this form of conditional statements. Okay, so here's an example of a conditional statement. If x and y are even integers, then x plus y is even. So this is a statement. It is a sentence that's either true or false. This happens to be a true statement. Do you believe it? It should, right? I mean, it makes sense, right? You, from your experience, just dealing with even numbers, you add two evens together, you should get an even number, right? So it is true. So this is the level of the type of proofs that we'll be writing in this class. You guys will be able to write. There's a few short weeks, maybe a few classes, we'll get to the point where we'll start proving statements like this. We need more background a little bit. We need, we've talked about even. We'll have a very precise definition of what even means. So that's and that's how we'll have to have that before we proceed. But this is an example of a conditional statement. So it's an if then statements. Right? These are pervasive in mathematics. Okay. All right. So when you have a sentence like this, if P then Q, this conditional statement, the logic notation looks like this. So this is denoted by this. It's an arrow pointing from P to Q. So when you read this, when you see this symbol, you can read this. One way to read it is if P then Q. Another way to read this is P implies Q. It's another way to say that. So those two sentences mean the same thing. If P then Q is the same as saying P implies Q. Okay? So it's called a conditional statement. What it's saying is that Q is true, but there's a condition. P has to be true first. So if P is true, then it forces Q to be true. So that's condition. So that's the conditional statements. Okay. So I'll also read this. So this is also read. P implies Q. Okay, so they're synonymous. I mean, there are two ways to read the same thing. P implies Q, or if P then Q. Okay. All right. I've got a conditional sentence, conditional statement for you. All right, 2014. Is this an election year? This is an election year, isn't it? Even years or even election year? Suppose I'm running for office. Here's my conditional campaign promise to you. If I am elected, then I will lower taxes. For a common campaign promise. So, are there any politicians that are honest anymore? If I'm elected, then I will lower taxes. So let's look at the circumstances when you would call me a liar. Well, if I told you I'm a politician, you call me a liar. But just assume, just based on this one statement, if I'm elected, then I will lower taxes. So when would I be lying? In other words, when is this a false statement? Okay? Think about this. First case, suppose I'm elected. Okay, suppose I'm elected. And I lower taxes. Would you consider me to be lying? No, I've kept my promise, right? So I'm telling the truth. All right. Now, suppose I am elected and I don't lower taxes. Would you consider me to have lied? Am I a liar? Yes, I'm a liar. So this is, so my original statement is false. I lied. Suppose I am not elected. And I realize there's more money in being a lobbyist than actually being a politician. So I do some lobbying, and so say through lobbying, I convinced the people that did get elected. I actually get taxes lowered. So through lobbying, I manage to get taxes lowered. Would you say my original statement was true or false? True. It's actually, I haven't broken my promise. I told the truth there. I said, because my promise was if I'm elected, then I'll lower taxes. And I didn't even get elected, and I still work to get taxes lowered. So my original statement would still be true. I have not broken my campaign promise because I was not elected. Okay. Now, suppose I am not elected, and taxes aren't lowered. Have I kept my campaign promise? You can't call me a liar. I mean, I only promised lower taxes if I was elected. So my original statement was still true, telling the truth. So what I've actually done is I've made a truth table here. Think of, if I'm elected, then I will lower taxes as the truth table, or as the statement, if P, then Q. Okay, so P would be, I am elected. Q would be, I will lower taxes. Okay? So let's look at the truth table. In other words, P implies Q. Okay? So let's look at the truth table here that we came up with. P, Q, and then P implies Q. So we had true, true, false, false, true, false, true, false, right? True, true is I am elected, I will lower taxes. So P implies Q is true. I am elected and I do not lower taxes. That's false. So P implies Q would be false. Okay? I'm not elected, so P is false. But through lobbying, I lower taxes. So Q is true. Well, my original statement is still true. I'm not elected, taxes are not lowered, so both statements are false. My original campaign promise is actually still true. So this is the truth table for P implies Q. The only case where P implies Q is false is when P is true but Q is false. So in your truth table, if both statements are true, then it's true. If P is true, Q is false, then P implies Q is false. if P is ever false, then it doesn't matter what's going on with Q. If this condition never happened, then it doesn't matter what the second sentence was. You know, if I said like, if the sky is green, then I am the king of France. That's a true statement. If the sky is green, then I'm the king of France. That's a true statement because the sky is not green, so it doesn't matter what conclusion I the second sentence. Okay. All right. So the only case when P implies Q is false is when P is true and Q is false. There's some alternate wordings. I mean, if P then Q is by far the most common conditional statement, but you use this when you're writing proofs. You use this symbol a lot. P implies Q. It's just you have a sentence and you just say that implies the next sentence, and you can write like a paragraph long proof, and you kind of use this symbol a lot. So that implies this implies that. It's used a lot. But let me list some other wordings, and the homework from this section will actually be dealing with these alternate wordings. Okay. So you already know if P then Q, you know P implies Q. How about Q if P? So think about that. It might help. Some of these might be helpful to actually substitute real sentences. Like if I said, if I'm elected, then I'll lower taxes. And then this one would be, I will lower taxes if I'm elected. See how those mean the same thing? And we kind of, should make sense in English. Q whenever P. That example again, like I will lower taxes whenever I'm elected. So that forces Q to be true exactly when P is true. P is a sufficient condition for Q. Now we're getting kind of math speaky here. P is a sufficient condition for Q. Okay, we're getting more technical here, and this is you do see these kind of phrases in math literature. P is a sufficient condition for Q. P only if Q.
That be the same as if and only if?
No, it's not the same as if and only if. That is a biconditional statement, which is the next section we'll talk about. Okay, that would mean both implies P implies Q and Q implies P.
On that one, is it P dependent on Q instead of Q dependent on P?
Well, the way I think of it is P is true only if Q is also true. Okay? So the only way that P could be true is if Q is also true. That's kind of the way I would think of this one. And again, this is the reason why I even mentioned this one. I would never write a sentence like that. I would it's much easier to say if P then Q.
That's not equivalent to P implies Q.
It'd be like Q and P.
Okay,
I would think it would be Q only if P.
Yeah, Q only if P.
No, it's Q if P, but it's different. So we'll combine these. Again, the only reason I'm going to mention this one is because when you combine these two, we'll talk about an if and only if statement in the next section, biconditional statements. Okay, again, the way I think of this is like P is true only if Q is true. They go to get like if P is true, then Q has to be true. That's what we're saying. P implies Q.
So did you just reverse the variable for having letters? Is that
And you're saying Q implies P? That's
well,
different
all
from P
along
implies
you've been
Q.
saying that P is the first thing and Q only happens if P happens, and so now you just changed it to now P can only happen if Q happens.
Yeah, this one is this is saying that if P is true, then Q has to come along for a ride. It has to be true as well. So I mean I think that P is still first here. If P is true, then that forces Q to be true.
If P only then Q.
Yeah. So when you're writing your math doctorate dissertation, do not use this phrase. I mean, so it's just, but it is, this is alternate wordings that just are uncommon. That it is like almost confusing. I mean, so why would you try to write a sentence that's confusing? So I would not use this particular phrasing. I would stick with really if P then Q. I mean, if X is even, then X squared is even. I mean, those are kind of sentences that we're gonna. It won't be confusing when we back here proving statements. They'll be written in the if-then format. Okay, I'm just presenting this. This is one of the options that the book also mentions for alternate wording. So, P can be true only if Q is true. So, as well. So. How about that? You like that better? So, all right. Let's talk about some homework from this section. And so it kind of makes you think about the wording here. There's going to be some sentences like P is a sufficient condition for Q, and they'll actually have words in there, and they just want you to make it kind of the plain vanilla conditional statement if P then Q. And those are some of the problems here. So page 42, number 2, 4, 5, 7, 8. Okay, and if there's some in there that you're not sure about, feel free to look at the odd number problem. I mean, I cited a couple of odd number problems because I really just want you to think about the formation of the sentences and see that that it can be just written as if P then Q. Okay. All right. We don't have time to start next week. 2.4. All right. So 2.4, we'll start next time on biconditional statements. So just real quick, saying that P implies Q, that's not the same as saying that Q implies P. Those are not the same. Okay. You can kind of convince yourself that make yourself sense. So I'll talk about that more. But there are cases when there are statements that P implies Q and Q implies P, and those are called biconditional statements. We'll talk about that on